Okay, welcome back to the Journal Club. Today we're going to discuss a paper from the 60s by a person by the name of Jacques Miller. And he always signed his name in his papers by, he had four names, J.F.A.P Miller. And when I was growing up in the business, I thought, well, that's sort of strange. I wonder what his names really are. He was French, and so Jacques Miller, but Miller's obviously an Anglican name. But his whole name was Jacques Francois Albert Pierre Miller, and he has an unusual history. The title of this paper, which is a classic in immunology, is the effect, because this establishes the fact that the thymus is an immunological organ on the one hand, and on the other hand is responsible for the embryogenesis and the maturation of the immune system. So that's pretty important. The title of the paper is The Effect of Neonatal Thymectomy on the Immunological Responsiveness of the Mouse. It was published in the Proceedings of the Royal Society of London, Series B, which stands for biological sciences. And it was published in 1962. It turns out that the timing of all this stuff is very important, and I'll see if I can relate that to you. He put a shorter version into the Lancet, which is the clinical journal in Britain, which is equivalent to the New England Journal of Medicine in the States. So he put in 1961, he put a shorter version out, and he says, well, the thing is, the background that I'm going to be giving you now is in his own words, really written. But he was asked to write his biography by the Annual Reviews of Immunology, and it came out in 1999. And I urge you all to access it online and to read this biography, because it's very well written, and it really tells the story of this fellow, which I'll try to give you a little flavor of. The whole thing it starts with his father, whose name was Maurice Meunier, and he was born right at the turn of the century, 1896, and he was French. And he came from a long line of French intellectuals and well-to-do people, and he became a banker. Just when he was a young man, around 25 or so, he left France altogether and he went to China, and he worked for a bank. This is when he became a banker. He started working for a bank in Beijing, and he stayed there for 22 years, essentially. So between the time that he was 25 and say 50 or so, he was in China, and he spoke several languages. He speak and write Chinese and Japanese and all kinds of things, this guy, and obviously French and so forth. But it turns out in the 30s, Jacques had two older sisters, and one of them got really sick, and so his mother left China and went back in the early 30s, went back to France so that his sister could be cared for by the French instead of the Chinese. And that was when Jacques was born. He was born in Nice on the French Riviera in 1931. So that puts this history of immunology is basically the history of the world, because as we'll see, and as you'll get into it, his whole career was influenced by World War II, obviously. So he was born in Nice in 1931. And then when the war came along in 1939, his father and his mother decided to go. They had been in France for maybe a decade at that stage. They went back to China, and he took up his banking situation in China. And then in 1941, after the Nazis had invaded France, and his father became a revolutionary, anti-Vichy and anti-Nazi and so forth, and worked for the resistance the whole time. Things were getting so hot that in 1941 his father decided to get out of there and out of China, and Japan was just before Pearl Harbor, 2 or 3 months before Pearl Harbor. They hadn't attacked the United States yet. Anyway, they got the British banking people got him British passports, and they emigrated to Australia in 1941. And at that time, Jacques was only around 10 years old or so, 10 or 11 years old, and so he grew up in Australia, and he became an Australian. And when he became a little bit older, he went to medical school in Sydney at the University of Sydney. And then this is where his career, his scientific career took off. And he decided he applied for a fellowship. And it was sort of a prestigious competition kind of thing. And he got that fellowship, and they, the round trip ticket to Britain. By this time, it was at the late 50s when he graduated from medical school and so forth. So he was around 25, 6, something like that, 27. And he had to apply to different research institutes in the UK, which he did. And he was accepted by the Chester Beatty Research Institute in London. But he then was assigned to they had a sort of a branch out in the countryside about 30, 40 miles from London in the bucolic rolling hills, sort of like Downton Abbey out in the countryside, you know. And he started working for this one fellow, but just as he started working for this one fellow because this fellow wanted to work on gross leukemia virus, and that was interesting. And from the standpoint of what happened to Miller, yeah, I forgot to say when he immigrated to Australia, they changed his name from Meunier to Miller. And that's what the French word means. And so Miller is the same word, except it's anglicized. When he started his research, and he was then enrolled in the University of London for his PhD, and lo and behold, as he got started in this whole process, his mentor was offered a job to be the head of another research institute. And so he took up and left. And so here, you know, Miller was out in the countryside. And but he said the good news was that he got to occupy this guy's lab, and he needed space because he was using a lot of animals, a lot of mice for these experiments on gross leukemia virus. And you know, and he points out at that time in the late 50s and so forth, it still wasn't accepted by most people that cancer could be caused by viruses, even though Peyton Rouse in around 1910 or 1915, I can't remember which, had first described Rouse sarcoma virus, that he was ignored, and all the rest of it was ignored until the 50s, really, when more and more viruses had been identified, and a lot in the mouse, friend leukemia virus from Sloan Kettering, and Rauscher leukemia virus from the NCI. And so gross leukemia virus, it wasn't really a virus yet. It was still just a preparation that you could pass from one leukemic mouse, make them homogenate and put it into another mouse, and that mouse would also get leukemia. And so it turns out that the leukemia that this virus caused arose in the thymus first. And so Miller decided that, well, that was where he ought to be doing experiments. And so he worked out a method to do a thymectomy. And what it was is he took a Pasteur pipette, a short glass pipette, heated it up at the end of it over the Bunsen burner, and just made a U-loop in that. And then he could put it, the thymus is right above the sternum, the breastbone. So he could stick that Pasteur pipette down there and suck out the thymus. And he got to be really, really good at it. And his technique then went, you know, all over the world subsequently and so forth. And so he started thymectomizing mice and so forth. And he noticed a bunch of things in his experiments with the leukemia. He was focused on whether the thymus was necessary for the generation of the leukemia or not, and so forth. And so he was doing all these experiments. He started doing thymectomies on newborn mice, 1 or 2 days, 3 days old. He used the same technique. He would put the thing down there and suck out the thymus. That was the beginning of this paper, essentially, that was published in 1962. And incidentally, he became a PhD student in 1958. And one of the things that I forgot to say, but I meant to say is that, you know, the interesting thing about Miller is that all the papers, classic papers that he published in the late 50s and early 60s, he was the sole author. It wasn't anybody else. It was almost, you know, where's the mentor? Or he basically didn't have a mentor because when his mentor went off to become the head of the research institute, Miller was left on his own devices. And so if you're a budding young immunologist, sometimes that can be very good. You don't have these guys looking over your shoulder telling you to do this and do that, and then taking all the credit, right? That's what they do, these leaders of the labs and so forth. Miller, during his PhD years in the late 50s, early 60s, he already had 4 papers out in Nature as single author papers as a student, you know, not bad for a startup on this guy's. In order for him to have a real PhD experience and so forth, he had to have somebody as a mentor. And so the head of the Chester Beatty Institute, who was really in London, a fellow by the name of Alexander Hadow. He was already a member of the Royal Society, and also he'd been knighted by the Queen, so he was a Sir. So he was a big deal in the UK, and he was critical to all the things that happened to Miller, even though Miller didn't have him looking over his shoulder because this guy was off in London. He helped him, and my experience has been is that there's only a few senior leaders of the lab who actually, when they come across a young up and coming star, whether they help them, a lot of times they hinder them because they're threatened by these young types. Anyway, the introduction of this paper, Miller points out several different things. He said, first of all, it seems like the function of the thymus in the literature and in the business is sort of unknown. It's a collection of lymphocytes in the upper chest, what it does. And when they've looked for antibodies under the histology under the microscope and so forth, or plasma cells that make antibodies, they knew this by that time, because Figueres from the Karolinska Institute had delineated that in 1948. There weren't any antibodies in the thymus. So how can it be an immunological organ or important for the immune system? There aren't any antibodies, because antibodies was all there was as far as most people were concerned about in terms of what immunology, what the immune system and the immune response really was. The only thing, the hooker in the whole thing was that people had done, after Medawar published his paper in 1953 about graft rejection, skin graft rejection, and then graft versus host disease. If you took thymocytes and you put them into a neonatal mouse, a newborn mouse, you end up with as the mouse grew up, you'd end up with graft versus host disease. You could also put the thymocytes into an F1 mouse that was a cross between the mother and the father and so forth. They would get graft versus host disease. And graft versus host disease really wasn't named yet, but they'd called it runt disease. And they could recognize the clinical picture of that whole thing. So it must have had the thymus must have something to do with the immune system. And of course, this whole idea of cellular lymphocytes mediating the immune system is still in a flux, and whether or not lymphocytes were important or not. And if lymphocytes weren't important, then why were thymocytes important? So that's the way they're thinking about it. And the other thing that he also points out in the introduction is when people said, well, let's thymectomize some mice to see what happens to the immune response. And we could look for antibodies and so forth afterwards. So they thymectomized adult mice that had been through puberty and had adult stature. Nothing happened. They made antibodies just fine. There was no problem. So the whole field, and this has been going on for a decade or more. Everybody said, well, the thymus is whatever, who cares about it? It's nothing. And this is important in terms of this paper and also what subsequently happened to Miller. But Miller said to himself and in his introduction, he said, since if you look at the thymus of a newborn mouse, and then over the course of the development, particularly over the first several weeks, the thymus is huge by comparison. It takes up the whole upper chest here. But then after puberty, after 5 to 6 weeks, then the thymus starts to shrink down again. And he knew that, and he pointed that out. And he said, maybe what that means is that the thymus is important early on in the life of the animal and in the developmental process of the immune system. And therefore, what we need to do to study this is we need to take the thymus out, not when it's an adult, but when it's a newborn. And so that's why he already had the technique that he'd worked out as a student and so forth, so he could do those experiments. And most people just did a hatch job on the thymus, didn't do a complete job and therefore would leave residual thymus around. And then, so therefore afterwards, if you didn't have a clean thymectomy, you didn't have a clean experimental system to be able to interpret anything that happened downstream. The materials and methods that he used in this paper were pretty straightforward. Histology and antibody assays and so forth that were already devised in addition to the thymectomy, neonatal thymectomy. And he goes on to the results. And in the results of this paper, the first thing he mentions is the gain in weight, or the growth of the mouse over time. And over the first month, 28 days. He also did sham thymectomies, which was he would also go into the same place into the thorax, but he wouldn't suck out the thymus. But he'd put one suture in the same way he did the thymectomized mouse and did everything else. So he did his experiments on littermates from the same pregnancy. So he was being very careful in terms of controlling the variables that he had to deal with. And so he would then compare first of all, just weighed the mice every day. You pick them up by the tail and you put them on a scale and you mark down the weight of the mouse. Pretty great methods in order to figure out what's going on. And it was just no difference. For the first 28 days, the mouse grew fine and looked great and gained weight, and it was not a problem. So that was the first month. And the mice would then stay there pretty much. And after the first month, then they would go through puberty and they had adult stature. And so after the second month, the mice started to do poorly and they started to die off. And so that after 4 months, 2/3 of the mice had died. And the question was, why was that? And just before they died, in the several weeks before they died, they ultimately died. Basically, they underwent a syndrome that looked just like graft versus host disease. They became runted or stunted in their growth. They started to lose weight instead of continuing to gain weight. They were lethargic, moving around the cages and so forth. And they had ruffled fur. They looked terrible. They got conjunctivitis. They had a hunchback. They started having diarrhea, and then they would die. Not a good thing. And it's very interesting in this. This is that observation of what happened to these mice after the second month. Turns out it's very important decades later in the history of immunology. And we'll ultimately get there if we last through all of these papers that we have to read getting there. But the next thing that happened after Miller's paper in 1962 didn't happen until 1981, 82, from a fellow from Japan by the name of Shimon Sakaguchi, who decided to look at this phenomenon of the runting mouse that had the neonatal thymectomy. So for 20 years, nobody looked into it. And what Miller was focused on was just to be able to make the conclusion, the interpretation, that the thymus was important for the development of the immune system. And so then what he did was after 6 weeks after thymectomy, he would bleed the mice through his tail vein and simply do a white blood cell count and differential on these mice. And he found that the thymectomized mice had a lymphopenia. They'd lost about 50% of their total lymphocytes, but all the rest of the white blood cells were just fine and they were normal. So that first month, 6 weeks, the bad things started to happen to the immune system. So then he would then sacrifice mice around the same time, 4 to 6 weeks. And he looked at then histologically at the spleen and the lymph nodes and so forth. And he found that there was an involution of the whole immune system, it wasn't an involution, it was just a failure of development of the lymph nodes and the spleen and so forth. So that was also pretty dramatic. There's about more than a 50% difference between the sham thymectomy and the thymectomized mice. And finally, he immunized these mice at different stages to different kinds of antigens, and he found that the thymectomized mice couldn't make antibodies. That was pretty dramatic too for all those people that thought antibodies were the sine qua non of the immune system and so forth. And then And he describes this in his annual review of immunology thing from 1999. He decided he wanted to see whether or not these mice that had been thymectomized at birth, whether or not they could reject skin grafts. So he said he went to a meeting of the Royal Society in London where Medawar was going to be talking. And you have to remember, this is just a few years after he published his 1953 paper. So after evidently Ed Medawar gave a lucid, wonderful talk about his skin graft experiments and so forth. So afterwards, Miller went up to him and asked him whether or not, he told him what he was trying to do and whether or not he'd teach him how to do skin grafts on these mice. And so Medawar didn't do it himself, but he had his right-hand man, Leslie Brent, do it, help Miller. And Miller says he spent a lot of time with him, getting him so he got the techniques just down and so forth. He would, the first experiment he did before the skin grafts is that he would take the neonatally thymectomized animals, and he would then wait until they grew up a little bit, and so that he figured that they were tolerant, and he would then transfer lymphocytes from normal animals, and in particular normal animals that had been immunized with another mouse's immune system and so forth. And so he would inject those immunized lymphocytes into the neonatally thymectomized mice. And now he found that those mice would reject skin grafts, whereas before they wouldn't reject skin grafts. And so he ultimately, after he'd done all of these experiments, he sent a short paper to the Lancet, which was published at the end of 1961, and he was encouraged to do this by Alexander Heddo, and so he was watching out for Miller. And at the same time, Heddo arranged for this paper to be published in the Proceedings of the Royal Society by Miller. It was transmitted to the Royal Society in January of 1962, and it didn't come out until several months later. But what these people were doing, Heddo, Miller, and so forth, was they were planting their stakes in the ground, their lances, because there were other people that were sort of breathing up their backs. And one of the groups was from the United States, and it was from Minneapolis in the pediatrics department. And Robert Good was a researcher out there who also had come on to the idea that the thymus was very, very important. And he came at this from a clinical standpoint because he was a pediatrician, because at that time it was known that there were kids little babies that were born that were immunodeficient and that they didn't have any thymuses. And when they didn't have any thymuses, they could still make some antibody, but not as well as a normal child. But in addition, or even more striking, they said they couldn't handle viral infections and fungal infections. And so Robert Good they were right on the tail of Miller. And subsequently, they became rivals, the Good people and Jacques Miller. And so those were the data in the results section. And in the discussion, he's a single author on this paper, and I'm no doubt that he had help writing this paper. But this paper is a very well written paper for a young investigator to do. If you read this paper carefully, and you realize that the guy was only 30, 31 years old, who did all these experiments and so forth, you think, well, this guy was top drawer, no doubt about it. He divides up his discussion into three different areas: lymphocyte depletion following thymectomy, immunological status of the thymectomized animals, and the relation to other states of immunologic failure. And he discusses each of those situations in his discussion. And before he gets into the discussion, he points out that there's some precedence for the findings that are described in this paper, because in 1960 there was a paper out about chicks, which ultimately the Good group got into, as we'll see. And it turns out that in 1956 there was a group from Ohio State University, which was one of my alma maters, and so I've always had warm spot in my chest for these guys. Glick was the fellow's name. It was in the Journal of Poultry Science. In the veterinarian school at Ohio State, they were doing immunological experiments on chickens, and they had used some chickens that had been used in other people's experiments where they had bursectomized the chickens. Now the bursa, it's called the bursa of Fabricius. It's sort of like an appendix outpouching from the colon of birds. Turns out that when they bursectomized chickens, particularly neonatal bursectomy, they didn't make any antibodies. So it's sort of like neonatal thymectomy, except it's in the bursa rather than in whatever. And so there was this that was in the literature from 1956 and 1960, and then in 61, somebody had made a report on rabbits where they had done neonatal thymectomy, and they found out that those rabbits, when they grew up, couldn't make any antibody responses. And so, what he's trying to do is establish the generality of his findings that are done very meticulously in the mouse with these other kinds of things. And he goes on to say that in terms of the lymphocyte depletion that followed the thymectomy, the question at the time was whether those lymphocytes that were found in the thymus, whether they left the thymus and populated the periphery or not. And he says that the fact that if you can thymectomize them in a neonate, that's entirely consistent with the fact that ultimately the way lymphocytes populate the lymph nodes and the spleen and so forth, the rest of the body, is like a lot of them are coming from the thymus. So that was number one. In terms of the immunological aspect of these thymectomized animals, he said all of the data that he talked about in his paper were entirely consistent with the fact that in the thymus, those cells are precursor cells, progenitor cells of the lymphocytes that are in the periphery later on in the adult. So there's an embryogenesis and a developmental process going on that has to do with very important for the immune system. And then in terms of other states of immunological failures, this is when he started sort of speculating about the fact that this rump disease that happens later on to these neonatally thymectomized animals, very, very similar to graft versus host disease. But he left it there, just made those conclusions. And so what happened then subsequently was that, so this is 1961, 62. He makes a point at the very end of his paper to say that he announced and showed all these data at a meeting in London that took place in November of 1961. And he puts that in his paper here in 1962 because it was a very, very important time. The timing was very important. And finally, he said that he was very indebted to Professor Alexander Haddow. And I've just told you why he was so indebted to him. But what happened subsequently is that then for the next decade, for a whole decade, Jacques Miller went on to publish several more papers and variations on the theme of these things in this paper, 4 papers in the Journal of Experimental Medicine, another couple of papers in Nature and so forth. And so he was clearly on the circuit during this decade, so between the ages of 30 and 40 in his life. And the problem was that Sir Peter Medawar, as well as other of the cognoscenti of immunology, found his data hard to believe, hard to swallow. And of course, he was just a young guy. He wasn't, a big deal or anything like that. And so they basically discounted his stuff. And he suffered from that throughout the rest of his career, really. Finally, by the end of the 60s, then everybody said, yeah, he was right. But in the meantime, they sort of really put him through the gauntlet. And a lot of people, said it was total BS and so forth. I think this paper is, in addition to the fact of all of his findings that were so meticulously and well done and then well written about in his paper, his history as a young person trying to make it into the the glitterati stage of his career are really interesting, particularly for those of us who are just starting out now in the biz. So if you like this video, like it online and subscribe to the newsletter where I'm serializing my new book, which is a memoir of the first 20 years of my career at Dartmouth. And also subscribe to the videos, because then the people who do the video things will be very happy with me. Thanks so much. It's been great.